Good morning, everybody. Today we are going to discuss simple harmonic motion, and generally we call it SHM. Why SHM is so important that in every physics lecture we start with simple harmonic motion because other different types of vibratory or oscillatory motions can be explained only when we have the knowledge of simple harmonic motion. So, we are starting with simple cases of SHM. ये कैसे हो
इस पर क्लिक करके आप मिटाओगे मिट जाएगा सारा। वापस इसी पे क्लिक करोगे पेन आ जाएगा।
अच्छा पेन से करूँ चाहे इससे करूँ
हाथ से करो चाहे पेन से करो। सर पेन से अब लिख लीजिए।
These are three basic properties of SHM. It is periodic motion. Second, particle is acted upon by a force that always tries to bring the particle it at its mean position. And third, amplitude of motion remains constant with time. It means when the time elapses, the amplitude of motion remains constant. Now we come to first point it is periodic motion. It means simple harmonic motion is a periodic motion, but every periodic motion is not simple harmonic. We can understand it by taking some example.
इस पे क्लिक कीजिए और क्लियर कर दीजिए, ऑल क्लियर
ओके, अब यहाँ से
सेलेक्ट हो गया
suppose this is a toy and it starts from point A and go to point B with constant speed, and after reaching here it returns back, and after reaching here it takes time t, again it turns and move with same velocity, again comes here after time t. Every time during the motion it is reaching at point A after fixed interval of time. Therefore, in language of periodic motion, it is periodic, but it is not simple harmonic, because I am saying that this toy is moving with constant velocity, and at reaching B it again returns. But in simple harmonic motion, it is mandatory that when the particle moves, it is acted upon by a force continuously, and if force is working, it clearly indicates that velocity may not remain constant. Therefore, this is periodic but not simple harmonic. Second, this is the orbit of the earth, and this is our sun, and this is our earth, and it is revolving around the sun, and direction of force is towards the sun. No doubt this is also a periodic motion, but still it is not simple harmonic. Why it is so? Because the earth from here to here and again reach the initial point from different path. It reach here and again here. Therefore, it is not simple harmonic. Third case, we know that steam engine piston, when engine is moving with constant velocity, the piston also moving backward forward with constant speed, and it is periodic motion. But now we have to judge whether it is simple harmonic or not. To find it, we just put off the or switch off the engine. It will move some distance, and after covering some distance, it came to at rest. But we know that the position of piston may be anywhere inside the combustion or outside the combustion. There is no definite mean position of the piston. Therefore, we cannot say that it is simple harmonic. So, now we come which type of motion is simple harmonic. Yes. Suppose this is a rigid support and a small bob with the help of a string is suspended from a rigid support, and we give a small angular displacement theta. The downward force is mg. Now we decompose it into component mg cos theta, and this is mg sin theta. This component is balanced by the tension in the string. Now, mg sin theta is free. Therefore, this component of the force tries to bring the bob to its mean position. When it comes to mean position, it acquires some velocity, it goes forward. As it goes forward in opposite direction, again mg, this is mg cos theta, and this is mg sin theta. Again, when it is going away from the mean position, force starts to act. Therefore, during the motion is periodic, as well as the force always trying to bring the particle, that is bob, to its mean position, and mean position is definite. If we leave it, it will always here. Therefore, it is mean position is definite, force is continuously working and always brings to mean position. Therefore, this is very good example of simple harmonic motion. Now, I think you can visualize which one is simple harmonic and which one is not simple harmonic. Now, we come to discuss the equation of motion of simple harmonic motion. So, the force is proportional to displacement from mean position. So let mean position is at x like this. This is the coordinate system, this is origin, this is x0, and this is mean position. It means it tries to always be at this position. Now, by some external agency, we disturb it and suppose it is at here. So, from here to here, let this is x. Therefore, this is displacement. So, F is proportional to x minus x0. But force always works against the displacement. Therefore, displacement is this direction. Therefore, force must be like this, because displacement and displacement and force are vector quantity. Therefore, we, in order to show the opposite direction, we put minus sign. Now, to make the calculation or concept simpler, let the mean position at origin. If we make this, then x naught will be 0. So, f is proportional to minus x. This is the basic condition of simple harmonic motion. Now, the force, and this is displacement. Now, force is trying to bring the particle in mean position. It may be is in value weaker or stronger. So, in order to represent this nature, we write this like this: f is equal to minus kx, where k represent the nature of the restoring force. Restoring force means the force which tries to bring the particle at mean position. If force is weak, k will be small. If force is strong, k will be high. Therefore, we generally say k is constant of force which brings the particle to its mean position. Okay. Now, but from equation of motion, f is equal to ma, and this can be written like m dv by dt, and further it can be written m d2x by dt square. This is the motion equation. Therefore, comparing the two, we get m d2x dt square plus kx is equal to 0, or x double dot plus k by m x is equal to 0. Here double dot means derivative coefficient of x 2 times. So, we generally, to save the space, we write x double dot. Now, k is constant, m is constant. You should be very careful. K is the property of the force and m is the property of the particle, but both are constant. Therefore, k by m will also be a constant. Therefore, we make it some simpler form. So, like this. X double dot plus omega square x is equal to 0, where omega naught square is equal to k by m. K by m is constant, therefore omega naught square should also be constant. And k is the property of force, m is property of mass. Therefore, omega depends upon both the quantities. Now, this is a linear second order differential equation. Therefore, every differential equation has got some solution, and the constant of solutions depends upon the order of the equation. Therefore, the general solution of this equation will have two constants. So, general solution we write x is equal to a e raised to power iota plus b e raised to power minus iota omega t. In this is the solution. If I put here yes, now the constant a and b can be real, can be complex, and can be imaginary. If we say that a and b are real, then this solution will not be general solution, because it is concern of mathematics, but I want to say you just note it. If a and b are real quantity, in that case this equation will not represent general solution, because there will be only one constant. If both are imaginary, in that case again this reduces to a single constant solution, therefore it is not general solution. If we consider a and b as complex, in that case we got two constants. Therefore, from the knowledge of differential equation, a and b are generally complex until unless we are not given the condition, otherwise this is complex. Okay. Now, this is the standard equation. Now, I want to say something, it is very important. Suppose this is a equation, okay, where psi and x both are variable. We can say, in other words, psi is function of x. Now, this is the standard equation of simple harmonic motion, and its solution is this. If I compare these two equations, we find that both have got the same nature. How? You see, in this equation x double dot is nothing, it is d2x upon dt square. So, if I compare these two, so you see psi x is equivalent to psi and t is equivalent to x. If its solution is this, therefore, this solution will also be identical to this. So, what will be the solution? We can write like this: psi is equal to a e raised to power iota lambda, variable is x, plus b e raised to power minus iota lambda x. This is the solution of this equation. Another, if I write this equation also has got the nature of simple harmonic motion. Therefore, its solution will also be identical to this. The solution will be y is equal to a e raised to power iota under root alpha x plus b e raised to power minus iota under root alpha x. Why here under root alpha? Because when omega is square, then it is omega. Now, here the coefficient here is omega naught square is alpha. Therefore, in solution it should be under root alpha. So, I think by looking at the nature of the differential equation, we can immediately write its solution, because we are not after mathematics, we are after the concept which is related with physical natures. Okay. Now, we come to some conclusion from this equation. Yes, x is equal to a e raised to power iota omega t plus b e raised to power minus iota omega t. I have said that a and b are complex, okay, but I say that amplitude of simple harmonic motion is always a real quantity. Therefore, these a and b should represent amplitude. So, amplitude is real quantity. Therefore, in sine form I can write like this: x is equal to c sine omega t plus theta. This is the solution of SHM differential equation, where C is representing amplitude. You should be very clear. A and B in this solution are some constant, but if I say that A and B are not some constant, but they are representing amplitude, in that case the value A or B should give I some real value. After solving mathematically, we get this expression. If anyone of you want to how we get, he or she can discuss separately how we get. So, this is the, so we have to always remember this expression x is equal to sin omega t plus theta, where theta is called initial phase angle, means at a time t is equal to 0, what is the position of the particle. To understand the value of theta, you see, suppose this is a straight line and this is this is mean position, okay, and this is extreme position, this is other side extreme position. A and B are extreme position and this is O is mean position. Therefore, O to A, this is C and O to B is minus C. If I say that this direction is positive, naturally this is. Now, suppose at t is equal to 0, particle is at A. So, naturally, if I put here t is equal to 0, you see C sin theta, but x is C, because particle is here, therefore, x is C. C is equal to C sin theta. This implies sin theta is equal to 1, natural theta is equal to pi by 2. Again, suppose particle is here, in that case x will be minus C. If particle is at B at time t is equal to 0, t is equal to 0, so x is equal to minus C. Now, we write here in general t is equal to 0, so x is equal to minus C is equal to C sin theta. This implies sin theta is equal to minus 1. Therefore, theta is equal to 3 pi by 2. Okay? So, I think you get the point. What is theta? Theta just says where the initially particle was when I first time saw it. Okay? So, this is the theta. Now, for simplicity, we generally make theta is equal to 0 because it just gives the idea where the particle, but on the whole theta does not affect my calculation. Therefore, for make the calculation simpler, we generally put theta is equal to 0. Therefore, in that case x is equal to C sin omega t. This expression tells when a particle is performing simple harmonic motion, then at time t its displacement from mean position will be given by this expression. So, you have to remember always C is amplitude, means maximum value of displacement. Omega is natural frequency of oscillation of the SHM, because every particle, if acted upon by some external agency, it oscillates about its mean position, and time period of oscillation depends upon the nature of force and mass of the particle. Okay. Now, we come to some other uh, values which is related with motion. So, we know that particle is moving, therefore, it should have got some kinetic energy. Second, we are saying that it is always being acted upon by some restoring force. Therefore, it is clear that if force is working or acting on the particle and nature of the force is conservative, in that case it should got potential energy also. Therefore, we calculate the kinetic energy as well as potential energy. So, see, kinetic energy E k. From the definition of kinetic energy, E k is equal to half mv square, and this can be like this, m dx by dt whole square. This is half m d by dt of c sin omega t and whole square. Now, c is constant, therefore, it will come out of this half m c square. Differential of sin omega t is omega, because here is square, therefore, square cos square omega t. So, E k is like this, m is constant, c is constant, omega is constant. Therefore, if this is representing kinetic energy, therefore, these factor should represent kinetic energy, but this factor does not contain any dimension. Therefore, it is just some number and it is changing with time. Therefore, any physical quantity which changes with time, we say that it is instantaneous value of kinetic energy. So, we can write like this, E k is equal to E 0, because I am calling this factor as E 0 or cos square omega t. Now, this instantaneous value is changing with the time, therefore, we take always average value. So, average value E k, this is the symbol of average, is equal to definition of average 1 by t 0 to t E k dt. If I put the value of E k from here, the result comes out to be, you do yourself, and this will come E naught by 2. E k is where E naught half f C square omega square. Okay. So average value is half of E naught. Okay. Now we come to potential energy. Potential energy EP. From the definition, EP is equal to F dot dx integral. I think everyone knows this. Here should be minus sign or not? Yes, it should be, because potential energy negative of work done against the force. Therefore, okay. Now, minus F is minus kx, because in simple harmonic motion F is proportional to minus x, therefore F is equal to minus kx. So I have to put F here minus kx, and this is dx. Now k is constant, minus minus plus, and this is just half kx square. But it is simple harmonic motion, therefore x is c sin omega t square, and this is just half k c square sin square omega t. But k by m is equal to omega square, therefore k is equal to m omega square. I can like, so therefore it is just half m omega square c square sin square omega t. This is EP. From this expression, again we are having that potential energy is function of time, and any physical quantity function of time, therefore it is instantaneous at a particular instant of time. This is the potential energy. Therefore we should take the average. If I take the average, so average is same 1 by t 0 to t, this is EP dt. If I put the value of this, is again comes out to be 1 by 2 of 1 by 2 m omega square c square, and in previously I called it E naught. So this is just E naught by 2. Again same, average of potential energy is E naught by 2. Average of Ek was also E naught by 2. Now if I add these two, so total energy EP average plus Ek average is equal to E naught. You see, add कीजिए, जैसे ही add, as soon as we add we get this, and this is constant. Fantastic result. In simple harmonic motion, the total energy of the oscillating system remains constant, but you should be very particular. here I am considering only single force, which is restoring force only, and which always try to bring back the particle in its mean position. But in nature, it never happens so, because if pendulum is oscillating, what is happening? Gravity force tries to bring the pendulum to its mean position, but when it moves through the air, it is acted upon by viscous force. Okay? So, next time we will discuss damp force, damping motion. Okay, thank you very much.